Given that a ball is dropped from a platform of height 19.6 meters high. S- So here is a ball is dropped from the platform. So let us consider the displacement. Displacement is x meters, and we have the velocity v is equal to rate of change of displacement, that is dx by dt, and acceleration due to gravity. So here we can consider negative 9.8 meter per second square. So that is a value. We know that v is equal to u plus at. So v is dx by dt is equal to u plus a value is negative 9.8 into time. So that is dx by dt. In the case of initial velocity 0, u is equal to 0. So we can write minus 9.8 t, or dx is equal to minus 9.8 t into dt. Now integrating on both the sides, so we can write x is equal to minus 9.8 t square upon 2 plus some constant c, that is x is equal to minus 4.9 t square plus c. Now in the initial case, when initial velocity u is equal to 0, and here the time, initial time t will be 0, when t is equal to 0, and the displacement total length is 19.6. So we can write 19.6 is equal to minus 4.9 into 0 square plus c. So we get c is equal to 19.6. We got the value of constant, and hence we can say the displacement function is x is equal to minus 4.9 t square plus 19.6. And now to find out the value of t at the final position, the displacement x is equal to 0 here, means there is no displacement, 0. So when x is equal to 0, so we get 0 is equal to negative 4.9 t square plus 19.6, and here we can say 19.6 is equal to 4.9 t square, or t square is equal to 19.6 upon 4.9, so which is 4. So we can say from here t is equal to 2. So for 2 seconds we can say the displacement is 0. So we can take the range of time is 0 to 2. So we can go with an option 0 to 2 and minus 4.9 t square plus 19.6, which is our option B. Given that the function f of x is equal to x to the power of x. So let us consider y is equal to f of x. So we can write y is equal to x to the power of x. Apply logarithm on both the sides. So we have log y is equal to log x to the power x. So log y is equal to x into log x by using the properties log a power m, m into log a. And now differentiating with respect to x, we have 1 upon y dy by dx is equal to uv rule, x into differentiation of log x is 1 upon x plus log x into differentiation of x is 1. So we can write 1 upon y dy by dx is equal to 1 plus log x, or we can write dy by dx is equal to y times of 1 plus log x, and dy by dx is equal to x is nothing, y is nothing but x power x of 1 plus log x. So for logarithm to be defined, x must be positive. So in the case of x is positive, x power x is always positive. So one, for the function to be increasing, dy by dx must be greater than 0 for increasing function. So we shall consider dy by dx is greater than 0, so which implies 1 plus log x must be greater than 0. That is, log x is greater than minus 1. So we can write log x is greater than minus log e to the base e, we can write. So here also base is e, and here since base e is greater than 1, so we can consider x is greater than, let us simplify and write log x to the base e is greater than log e to the power minus 1 to the base e, that is x is greater than e to the power minus 1, that is x is greater than 1 upon e. So for the function to be increasing, so the x value must be, x must belongs to 1 upon e to infinity. So option D. So option D is the answer. A cylindrical gas container is closed at the top and open at the bottom. So let us consider cylindrical container which is closed at the top and open at the bottom. And also, if the iron plate of the top is 5 by 4 times as thick as the plate forming the cylindrical sides. The cylindrical plate thickness is, if suppose let us consider the thickness is x here, the top will be 5 by 4 times of x. Then the ratio of the radius to the height of the cylinder using minimum material. So let us consider, or we know that the volume of cylinder V is equal to pi r square h, which is constant. So which implies that h is equal to V upon pi r square, and surface area is equal to 2 pi r h plus pi r square, because it's open at only one end top, and sorry, open at bottom and closes at the end top. So we can use only 1 pi r square. And let us consider the material used, or we can say volume of material, not volume of the gas container, it's a volume of material. Let us consider to be capital S is equal to 2 pi r h into the thickness of the sides is x, and pi r square into the thickness of the top is 5 by 4x. And we can also use from 1, 2 pi r into x into h is equal to V upon pi r square plus pi r square into 5 by 4 into x. So here we can simplify and cancel here. We can take x common, 2v upon r plus 5 by 4 pi r square, and this is the volume of the material. Since we required minimum material used, so for minimum we must consider ds by dr is equal to 0. So differentiating, we'll get ds by dr is equal to x times of 2v into 1 upon r differentiation minus 1 by r square plus 5 by 4 pi into 2r is equal to 0. So here we can write minus 2v upon r square plus 5 by 2 pi r is equal to 0, or we can say 5 by 2 pi r is equal to minus 2 upon r square into, and v value we can consider to be pi r square h. So we can cancel r square and he can cancel even pi on both the sides, and hence we can say r upon h is equal to so minus 2 upon, sorry, this is plus 2 into 2 upon 5. So we can say this is 4 upon 5. So r by h is equal to 4 upon 5 we can consider, and make sure that we can say the double differentiation d square r by dr square, even if I differentiate, so it will be positive. Whenever it is positive, we can consider for the value of r upon h is equal to 4 by 5. This minimum material gives the minimum. Volume of the material is minimum. So we can consider 4 by 5 is the answer, option C. Line joining the points 0, 3 and 5, minus 2 is a tangent to the curve. It's a tangent to the curve y is equal to ax upon 1 plus x. So let us find the equation of the tangent, equation of the line. Equation of a tangent joining through 2 points. So we can say y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. So let us use the points. Y minus 3 upon x minus 0 is equal to y2 minus y1, that is minus 2 minus 3 upon x2 minus x1, that is 5 minus 0. So y minus 3 upon x is equal to minus 5 upon 5. So we can say y minus 3 is equal to negative x, or we can write y is equal to, or x plus y is equal to 3, or we can say y is equal to 3 minus x. So we got equation of a tangent is x plus y is equal to 3, and to make sure that this line is a tangent, x plus y minus 3 is equal to 0 is a tangent for the curve y is equal to x plus 1 upon x. So it must give the equal roots. So if I substitute y is equal to 3 minus x here, so 3 minus x is equal to ax upon 1 plus x. So which can be written as 3 minus x into 1 plus x is equal to ax, or simplifying we can write 3 negative x plus 3x minus x square is equal to ax. So we can write x square, and here 3x minus x is 2x, so we can write minus 2x plus ax minus 3 is equal to 0, that is x square plus of a minus 2 of x minus 3 is equal to 0 is a quadratic equation. Since like given line is a tangent, so we must have the equal roots, that is delta is equal to 0. So discriminant, that is b square minus 4ac, so we can write a minus 2 whole square minus 4 into 1 into negative 3 is equal to 0, that is a minus 2 whole square a minus 2 whole square plus 12 is equal to 0, which is not possible since a minus 2 whole square is equal to negative 12, which is not possible, and hence we can say that a value must be empty set. So we can go with an option B. We need to find the values of a for which the function f of x is equal to a square minus 3a plus 2 into cos square x by 4 minus sin square x by 4 plus a minus 1 of x plus sine 1. So let us use the property here. Our a square minus 3a plus 2, we can write it as a minus 1 into a minus 2 factorization. And second, cos square theta minus sine square theta is equal to cos 2a. So we can write cos square x by 4 minus sine square x by 4 is cos 2 into x by 4, that is cos x by 2. So we can write f of x is equal to a minus 1 into a minus 2 into cos x upon 2 plus a minus 1 into x plus sine 1. Since this function does not possess critical points, we need to consider f dash of x not equals to 0. So differentiating, we can say a minus 1 into a minus 2 into minus sine x upon 2 into 1 upon 2 plus a minus 1 is not equals to 0. So we can write a minus 1 not equals to 0, and another part we can write minus of a minus 2 upon 2 sin x upon 2 plus 1 is not equals to 0, or we can write 1 cannot be equal to a minus 2 upon 2 sin x by 2, or we can write sin x upon 2 cannot be equals to 2 upon a minus 2. Means sin value cannot be equal to 2 upon a minus 2 means this 2 upon a minus 2 must be above plus 1 or below minus 1, because sin theta, since sin theta lies between minus 1 to plus 1, so we can say 2 upon a minus 2 does not belongs to minus 1 to 1. So we can say simply that 2 upon mod of 2 upon a minus 2 mod must be greater than 1. That is 2 upon a minus 2 is greater than 1, or 2 upon a minus 2 is less than minus 1, or 2 is greater than a minus 2, or we can write 2 is less than minus a plus 2, or we can write 4 is greater than a, or a is less than 4, or here we can say a is, so a is greater than 0. So a greater than 0 and a less than 4 is the condition, and also we have a is not equals to 1. So this is 1 and this is 2. So from 1 and 2 we can say a belongs to 0 to 1 union 1 to 4. We need to consider up to 4, but 1 is excluded, so 0 to 1 and 1 to 4, which is option B. Given two columns, the list one with the functions f of x is equal to cos x, f of x is equal to log x, and f of x is equal to x square minus 5x plus 4, and f of x is equal to e power x, and the other side describing about the graphs. List 2, we need to match the list 1 and list 2 with the codes, and f of x is equal to cos x, first one, and we can see that the cos graph, the graph of cos x will cut the x-axis at infinitely many points. The graph x cut the x-axis at infinitely many points, so we can go with an option graph cuts x-axis infinite points. So option A we can go with 5, option A we can go with 5, C and D is matching. And coming to the second one, f of x is equal to log x, and the log x graph, we can say log 0 is not defined, log 1 is 0, and log e value is 1, and here we can see the graph. We can see that the graph cuts the x-axis at one and only one point. Graph cuts x-axis in only one point. We can go with an option 4. So second B, we can go with 4. So either this or this. And coming to the third, f of x is equal to x square. Third one, C, f of x is equal to x square minus 5x plus 4, x square minus 5x plus 4. And if we see the discriminant, we can say b square minus 4ac, 25 minus 4 into 4, that is 16. 25 minus 16 is 9, which is positive. We can say that there are two roots, distinct roots, which indicates that the graph of this function will cut the x-axis at two different points. So graph cuts x-axis in 2 points, we can go with an option 2. So for C, we can go with a 2. And finally, we can see that option D, f of x is equal to e power x. And graph is considered to be e power x graph as it cuts the x y axis at only one point. When x is equal to 0, it is 1. So we can indicate that the graph cuts the y axis at only one point, option 3. So finally, we can say that it matches with the C, code C. We can go with an option C. What is the x coordinate of the point on the curve? F of x is equal to root x into 7x minus 6, where tangent is parallel to x-axis. Any tangent parallel to x-axis, we can consider dy by dx is equal to 0. So f dash of x is equal to 0, we can consider in this case. So that is differentiating 7 times, that is d by dx of 7 times x into root x minus 6 root x is equal to 0. That is d by dx of 7 times of x to the power of 3 by 2 minus 6 times of x to the power of 1 by 2 is equal to 0. That is 7 times x to the power into 3 by 2 minus 6 into 1 by 2 into x to the power of 1 by 2 minus 1. So we can write 21 upon 2 x to the power of 1 by 2 minus 3 times of x to the power of minus 1 by 2 is equal to 0. Or we can write 21 upon 2 x to the power of half is equal to 3 times of x to the power of 1 by 2 minus 1 by 2. So cross multiplication of 21 upon 2 x to the power of half is equal to 3 upon x to the power of half. So x power half into x power half is equal to 3 into 2 upon 21. So x to the power of half plus half is 1 is equal to 3 7 times. So 2 upon 7. So the value of x, the x coordinate can be considered as 2 upon 7, which is option B, for which the tangent is parallel to x axis. So x is equal to x coordinate is equal to 2 upon 7. A wire 34 centimeter long is to be bent in the form of a rectangle. Let us consider AB with a 34 centimeter, which is shaped into the form of a quadrilateral, of which each angle is 90 degrees. So if each angle is 90 degrees, it must be a rectangle. So let us consider x is the length and y is the width. So the perimeter is 2 times of x plus y is equal to 34 centimeter, that is 34. So x plus y is equal to 17, and it is now given what is the maximum area which can be enclosed. So area of the quadrilateral or rectangle, here we can say, is length into, that is x into y, and here we can write x into y can be written as 17 minus x. So x times of 17 minus x, and to get the area maximum, so differentiate dA by dx is equal to 0. So we can write x into, or this we can write it as 17x minus x square. So differentiating will get dA by dx is equal to 17 minus 2x is equal to 0, or we can write x is equal to 17 upon 2. So when x is equal to 17 upon 2, so y is equal to 17 minus 17 upon 2 is again 17 upon 2. It's a half of 17. So we can say that the rectangle must be a square to get the maximum area. So area of the square is equal to side square, that is 17 by 2 whole square. So we can say 17 upon 2 is 8.5 whole square. So 8 nines are 72, 72.25 square centimeter. So option D is the answer. Given that function f of x is equal to x to the power of 3 minus 1 for x belongs to minus 1 comma 1. So we need to identify whether this function is increasing and it has a root in minus 1 to 1. So let's differentiate. F dash of x is equal to 3x square minus 0, and here we can say that for any real number 3x square is always greater than or equals to 0. Even we can consider for x belongs to minus 1 to 1. So f dash of x is greater than or equals to 0, which implies that f is increasing. The given function is increasing in the interval minus 1 to 1. And now, since this function is increasing, and f of negative 1 we can write minus 1 whole to the power of 1 minus 1, which is negative 2, and f of 1 is equal to 1 minus 1, which is equal to 0. We can see that the graph for negative 1 it is minus 2 and plus 1 it is 0. So the graph will cut, since it is an increasing function, the graph will cut only at the point at x is equal to 1. And clearly we can say that from minus 1 to plus 1 there are no roots. Hence we can say f has no roots, no real root we can say in minus 1 to plus 1 open interval, because it has only root in plus 1. So we can go with an option. Option f of x has no root, it is correct. And this function f is increasing is also correct. So both options are correct. We can go with an option C, both 1 and 2. The tangent to the curve y is equal to e power x drawn at the point c comma e power c. Let us find the tangent equation to the curve y is equal to e power x. So differentiating dy by dx is equal to e power x, and to find the slope of the tangent at the point c comma e power c is equal to e power c. So this is slope of tangent. So we have slope y minus y1 is equal to m into x minus x1. So point slope form, let us use it. So we can write y minus e power c is equal to e power c into x minus c, or we can write y is equal to e power c of x minus c plus e power c, or taken e power c common, x plus 1 minus c. that is y. And now let us consider equation of the line joining the 2 points c minus 1 comma e to the power c minus 1 and c plus 1 comma e to the power c plus 1. So we get the equation of the line y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. So let us substitute y is equal to e power c into x plus 1 minus c here. So we can write e to the power c of x minus c plus 1 minus e to the power of c upon e is equal to e power c into e minus e power c upon e divided by 2 into x minus c plus 1. So here e power c taken common completely. So e power c of x minus c plus 1 minus 1 upon e is equal to e power c times of e square minus 1 upon 2e into x minus c plus 1. So we can cancel e power c on both the sides and we can write, so we can write x minus c plus 1 minus 1 upon e is equal to e square minus 1 upon 2e into x minus c plus 1. So let us consider x minus c is equal to some p. Let x minus c is equal to p. So we can write p plus 1 minus 1 upon e is equal to e square minus 1 upon 2e into p plus 1, or p plus 1 taken common. So we'll get 1 minus e square minus 1 upon 2e is equal to 1 upon e, or p plus 1 into 1 upon 2e, 2 is in 2e minus e square plus 1 is equal to 1 upon e, or we can write p plus 1 is equal to 2e upon e into 1 by 2e minus e square plus 1, or p is equal to 1 upon 2e minus e square plus 1, that is 2 upon minus 1. So we can write p is equal to 2 minus 2e plus e square minus 1 divided by 2e minus e square plus 1, that is e square minus 2e plus 1 upon 2e minus e square plus 1. So p is equal to e minus 1 whole square upon, and here we can take negative common, e square minus 2e minus 1. E minus 1 whole square is always positive, and here denominator is negative. E square minus 2e minus 1 is negative. So we can consider p is nothing but x minus c. X minus c is negative, that is x is less than c. So we can consider now to the tangent of the equation y is equal to e power x at the point c comma e power c to intersect the line joining these 2 points. Your x must be c, x must be less than c, means on the left of x is equal to c it is possible. So which is option A. So we can go with an option A. The curve y is equal to x e power x has minimum value. So we need to find the minimum value of the function. So given y is equal to x into e power x, so differentiate with respect to 2x. We have dy by dx is equal to x into e power x plus e power x into differentiation of x is 1 by using UV rule method. That is dy by dx is equal to e power x taken common x plus 1, or d square y by dx square is equal to e power x into differentiation of x plus 1 is 1 plus x plus 1 into differentiation of e power x is e power x, that is e power x of x plus 2, that is d square y by dx square. For minimum or maximum, we consider dy by dx is equal to 0. So we can consider e power x of x plus 1 is equal to 0. So e power x cannot be equals to 0 for any real number. It is always positive. So we can say x plus 1 is equal to 0, that is x is equal to negative 1. For x is equal to negative 1, to check whether this gives minimum or maximum value, let us substitute x is equal to minus 1 in double differentiation. So d square y by dx square at x is equal to minus 1 e power minus 1 into minus 1 plus 2, which is 2 minus 1, 1 into e power minus 1, that is 1 upon e. 1 upon e is always positive. And since d square y by dx square is positive at x is equal to minus 1, therefore we can say the curve y is equal to x e power x has minimum value. By the derivative test, we can see it has minimum value at x is equal to minus 1. Therefore, the minimum value can be taken. So y is equal to minus x minus 1 into e to the power minus 1, that is minus 1 upon e. So option A is the answer. The line which is parallel to x-axis crosses the curve y is equal to root x. So we can say y is equal to root x is the graph like y square is equal to x. It's a semi curve, and y is equal to parallel to x-axis means we can consider one line. It cuts the graph at one point at an angle of 45 degrees. Means tangent at this point is 45 degrees or 135 degrees we can consider. So let y is equal to some constant, y is equal to k is the parallel line to x-axis, y is equal to k be line parallel to x-axis, cuts the graph y is equal to root x, so which implies k is equal to root x, or we can write x is equal to k square. So when y is equal to k, so therefore the point of intersection can be is k square comma k. And now we need to find tangent, that is dy by dx for y is equal to root x. We can say dy by dx is equal to 1 by 2 root x, and dy by dx at the point k square comma k, which is equal to 1 upon 2 root of k square, which is equal to 1 by 2k. And the slope is given, and dy by dx at the point is given 45 degrees. The slope is given tan pi by 4, which is equal to plus 1 or minus 1. So we can consider 1 upon 2k is equal to 1, or k is equal to 1 by 2. So the equation of the line can be taken as y is equal to 1 by 2. Since y is equal to k is the line, so we can take y is equal to half. Since it is a positive square root, only semi curve will be there, so we'll take only positive value. So we can go with an option C. Tangents are drawn from the origin to the curve y is equal to cos x. Their points of contact lie on. We know the graph of cos x. Say this is origin. So we can draw the tangents. So let us consider the point of contact is say h comma k. We need to find the locus of this point. So given curve y is equal to cos x. So differentiating, we get dy by dx is equal to minus sin x, and we need to find the slope of the tangent at the point h comma k. So we can write minus sin h, and now the equation of the tangent we can write passing through the point h comma k. So y minus y1 is equal to slope, that is minus sin h into x minus x1, and this tangent equation is passing through origin. It is passing through origin, so we can substitute y is equal to 0 minus k is equal to minus sin h into 0 minus h, that is minus k, or minus k is equal to minus or minus plus h into sin h, or we can write sin h is equal to minus k upon h. Also let us consider this is 1. Also h comma k lies on the curve y is equal to cos x, so which implies k is equal to cos h. Say this is 2. Now squaring and adding 1 and 2, we get sin square h plus cos square h is equal to k square by h square plus k square, that is 1 is equal to k square of 1 plus h square upon h square, or we can write h square is equal to k square into 1 plus h square, or we can simplify and write here h square is equal to k square plus k square h square, or h square minus k square is equal to k square h square. Hence equation of locus, substitute in place of h and k, x and y, so we can write x square minus y square is equal to x square y square, which is our option C. So option C is the answer. So given curve equation y is equal to e power x into cos x, and its slope can be taken as dy by dx is equal to e power x into minus sin x plus cos x into e power x. So that is e power x taken common, cos x minus sin x, and here it is given we need to find the slope of the tangent to be minimum. So let us consider slope function as m. So let m is equal to e power x into cos x minus sin x, and we need to verify this function to be minimum, means we need to differentiate this. So dm by dx is equal to e power x into cos x differentiation minus sin x minus cos x, and again plus cos x minus sin x into e power x. So you can take e power x common, so minus 2 sin x minus cos x plus cos x gets cancelled, so 0. So we got dm by dx is equal to minus 2 e power x into sin x, and also d square m by dx square is equal to minus 2 into e power x into cos x plus sin x into e power x. So we can write minus 2 e power x into cos x plus sin x, that is d square m by dx square. And now for the function the slope of the tangent to be minimum, we need to consider dm by dx is equal to 0 at x is equal to alpha. So let us consider is equal to 0, so which implies minus 2 into e power x sin x is equal to 0, which implies sin x is equal to 0. Since e power x cannot be 0, it is always positive. So sin x is equal to 0 in the case of 0 to 2 pi. So we can say x is equal to 0, pi and 2 pi. And among these three options, we need to check whether the double differentiation is positive, because for minimum d square m by dx square must be positive. So let us check for x is equal to 0. So we get minus 2 into e power 0 is 1 and cos 0 is 1 and sin 0 is 0, so which is negative. And d square m by dx square for x is equal to pi, we can say minus 2 e to the power pi into cos pi is negative 1 and sin pi is 0. So we can add negative of negative plus 2 e to the power pi, which is positive. So we can say for x is equal to pi, the given function is having minimum. So we can say answer pi, option B. Given a and b are non-zero, roots of x square plus ax plus b is equal to 0, which implies that we can write x minus a into x minus b is equal to x square plus ax plus b. So which implies that x square minus of a plus b of x plus ab is equal to x square plus ax plus b. So we can consider here minus of a plus b is equal to a and ab is equal to b. That is negative a negative b is equal to a, or which implies 2a is equal to negative b, and here b a is equal to 1. When a is equal to 1, so we can write 2 into 1 is equal to negative b, or b is equal to minus 2. So when a is equal to 1 and b is equal to minus 2, you will be getting x square plus x minus 2 is the function. So let us consider f of x, or y is equal to x square plus x minus 2. Now differentiate dy by dx is equal to 2x plus 1, 2x plus 1, and for minimum or maximum we need to consider to be equal to 0. So dy by dx is equal to 0. So which implies that 2x plus 1 is equal to 0. So x is equal to minus 1 by 2. So when x is equal to minus 1 by 2, and in double differentiation we can write d square y by dx square is equal to 2, which is always positive, and hence we can consider for x is equal to minus half, the given function is minimum. So therefore f of x is equal to, or f of minus half is equal to, we can write minus 1 by 2 whole square plus minus 1 by 2 minus 2, which is 1 upon 4 minus half minus 2. Upon simplifying, we will be getting 4 is the LCM, 1 minus 2 minus 8. So which is minus 9 upon 4. So minus 9 by 4 is the minimum value, which is option C. So option C is the answer.